Hello everyone, welcome to this example video on the superposition principle. So the question that we're going to do reads determine Vx, and Vx is the voltage over the 6 ohm resistor. So we are going to need to determine the individual contribution of each of the three sources towards Vx, and then we're going to need to add all of these together. Right, so let's start off with the 15 volt source. For us to do this, we'll have to deactivate the other sources. So we'll have the voltage Vx due to the 15 volt right, and in place of the 19 volt source, we're going to have a short circuit, and because of that short circuit, the 10 ohm resistor will then be bypassed, resulting in a more simplified circuit. Right, and we are looking for the voltage Vx. We can then see there that the voltage Vx will be the same as the voltage over the 6 ohm, which is connected in parallel with the 5 ohm. So we can actually put those together to simplify the circuit. That will be the 6 ohm in parallel with the 5 ohm. Which gives you a value of 2.72 ohms, which will be now connected in series with the 5 ohm. And what's important to note is because these two were connected in parallel, that value of Vx won't change. So now we can determine Vx by saying, and let's denote this as Vx1, as saying that that is going to give me, using voltage division, 2,72 over 2,72 plus 5, all multiplied by 15. So Vx1 is going to give me a value of 5,29. Right, so that's the first part. Now we will look at Vx due to the 19 volt source. And for us to determine the Vx due to the 19 volt source, what we're then going to do is we're going to deactivate the other sources. So the 15 volt source gets replaced with a short circuit. The current source is replaced with an open circuit. And the only voltage remaining would then be the voltage of the 19 volt source. Right, and we can then push to determine the actual value that we'll be looking for Vx. Right, now how will we find this value for Vx? So first we can add these two in parallel, and that should assist us in terms of calculating the actual value of the equivalent resistance between those two. So that will be 6 in parallel with 5, which then should give us a value of 2,72, and the voltage there will be the voltage Vx, and that will be connected in parallel to the 19-volt source. Right, now how will we find the value of the voltage Vx? You could add the two resistors and get the parallel combination to then come back to get the current and then multiply it by the resistance to get the voltage. But it's also worth noting, which will be a simpler approach, that the voltage that is seen of the 19 volts is seen across the 10 ohms, and it's also seen across the series combination of the 5 ohm and the 2.72 ohm. So we can use voltage division and say the voltage Vx2 is going to give me the actual resistor value using voltage division, 2.72 over 2.72 plus 5 multiplied by 19. And that gives us a value of 6.69. Right, so Vx2 is 6.69 volts. Finally, we look at the final source, which is the current source. So if we determine Vx due to the current source, then what's going to happen is the current source will be active, whilst the other sources will then be deactivated. So you'll have your resistor short circuit, and on the right hand side you have the two resistors. That will be 6, that will be 5, that will be 10, and we will have 5 and the source value, which is 2 amps. Right, we should be able to simplify this, but we also need to take note of the fact that we're looking for the voltage plus minus Vx. So we put that together again and we will get a value of 2.72. This resistor will be bypassed because of that short circuit. And that's the circuit that we will have. 2.72, we'll have 5 and 2 amps. And we are still looking for the voltage there, which is Vx. So we will then determine first the current. This current will split as follows, and the potential will be plus minus according to passive sign convention. So we'll get first we'll get the current, I'm going to call it I. So I is going to give me 5 over 5 plus 2.72 times 2. And then that gives us a value of 1,29. Now I can multiply that out, so I can say v is 1,29 times 2,72. That gives me a value of 3,52 volts. Therefore, Vx is equals to negative V, and this is Vx3, which is then going to give me minus 3,52 volts. My final step would be to add all of these values together. So Vx is going to give me Vx1 plus Vx2 plus Vx3, which is going to be 5.29 plus 6,69 plus the negative 3,52. So Vx will give me the addition of these three values, which gives me a final value of 8,46 volts. So one is able to see then that the whole objective here is to treat all the sources independently, deactivate the other ones when you are treating them, when you're focusing on one source, and at the very end you add the final values together. Thank you for watching this video and enjoy the course.